Hey everybody, Michael Snyder, Pacific Northwest Weather Watch. Today's September 8th, and today we're doing a continuation of the greatest windstorms for the Pacific Northwest. You can see we've got an infrared satellite imagery here of December 12th, 1995, one of the greatest windstorms to ever strike the west coast of North America in recorded history. You see the low pressure center off of Oregon there. This slammed into the Olympic Peninsula in Washington, brought some pretty extreme winds all the way across some extreme southwest BC down towards central California, almost 1,000 miles. Very extensive reach that this storm had. As you can see, its cloud shield extended all the way down across the subtropics here. Cold air behind it, bent back occlusion, and the low pressure center again right there. Taking a look at the Seattle Times headlines in advance, we got about 3 to 4 days heads up for this storm. Meteorology started to get a little bit better, and we tracked this storm pretty well. And, like I said, 3 to 4 days in advance. And this is, I think, a couple of days in advance of the storm, or maybe the day before, but still calling for 80-mile-per-hour gusts. And that did verify across some of the Puget Sound. Taking a look at some of the wind gusts here, look at Mount Diablo, 130 miles per hour down in California, Newport, Oregon, Portland, Oregon, 62. Astoria 62, San Francisco an incredible 74. Look at Redding, California clocking in at 85 miles per hour. Bellingham right up near the Canadian border, 76 miles per hour. Enumclaw relatively sheltered from southerly winds there. They usually get their big winds out of the east from the Stampede Gap, and they got 60 miles per hour. Impressive showing there. Sea Lion Cave is probably the biggest gust on the Oregon coast at 119. Angel Island 103, Chinook, Washington, Puyallup, and interesting on ocean shores, usually a pretty windy location, but they were right next to the low pressure center there. So the biggest gradient and the most powerful winds just to the south and the southeast of ocean shores, Washington, as this storm made landfall into western Washington. And now we're looking at Auburn here at 70, Olympia at 65, Harbor Island near downtown Seattle, an incredible 78-mile-per-hour gust. Mukilteo, Washington, up towards Everett there, kind of right on the sound, 86 miles per hour. North Bend, 78. And now we're talking about California's history here, because this is probably the strongest storm to ever strike California in recorded history, at least according to the Bay Area Storm Index, BASI. Now, taking a look at what that is, you can see San Francisco, 24-hour rain. They do a criteria, and then they assign points, sustained wind, and then max wind gusts below 1,500 feet in the Bay Area. And as we look at that. December 12th, 1985, scored a perfect 10, beating other notably historic storms, including the bomb cyclone of 2021. You guys probably remember that, October 24th, and some other impressive storms of the past. But yeah, perfect 10 there. And I was given permission to use this Bay Area Storm Index here. You can see courtesy Jan Null CCM, Golden Gate Weather Services. Check out their website if you want to take a look at that. And you can see some of the headlines there from some of Central California there, San Francisco, hundreds of thousands of that power, actually about 1.5 million, but it was a pretty impressive storm. You can see it did a lot of damage. 2-day rainfall total for San Francisco, over 5 inches. Look at this, 1,000 trees blown down in Golden Gate Park. $15 million damage to the San Francisco Arboretum. Power outage just over 1.5 million PG&E customers. And look at this 135 mile per hour gust on a hill at 1,894 feet that destroyed the wind sensor. It buckled the radio tower and destroyed satellite communication dishes at the site. You can see there are other examples of damage. Roads flooded, homes being crushed by falling trees, broken glass due to wind-driven debris, 169 schools closed in the area, 14 inches of rain in a 36-hour period over the Russian River Basin. And look at some of the rainfall totals here. Actually, let's back here and look at that. You can see Dublin, San Francisco, Pleasanto, Alameda, Fremont, Hayward, Livermore, and Oakland. Very impressive rainfall totals. And we'll take a look at the meteorology with this as well, and take a look at the precipitable water in the atmospheric river that just slammed Central California. Idaho was hit hard as well. You can see some big winds. Spokane gusting to 55, power out for over 10,000 in the city. Cheney, 75 miles per hour. Rattlesnake Ridge, 93 mile per hour gusts here as well. Now, if you were looking at your barometer, I mean, you guys might have some of these barometers in your home, or maybe your grandma did, from the old school style stuff. But a lot of times these barometers don't move that much. I mean, a lot of times you'll look and it'll be between 30.2 and 29.8. But that morning you would have woke up and the barometer needle would have been all the way down, potentially even past this marker here. And you might have been tapping on the glass saying, what is wrong with my barometer here? And in the old days, this is the only real heads up you had to some of these storm systems moving in here. When barometers were first made, obviously you didn't have satellite imagery and all that. So you would kind of get your first inclination a storm was coming by the barometric pressure just plummeting during the day. And yeah, you might have seen one of these hanging on your grandma's walls at some point, or you might have one on your wall. They still are fairly popular. I have a few of these barometers still around the house as well. But SeaTac recorded its all-time record low barometric pressure to 8.65. And look at this, Cape Elizabeth there. I almost said Queen Elizabeth. Cape Elizabeth there at 28.31. Just very impressive storm. Moved up across the area. Destruction Island, 28.38. All kinds of records broken with regards to the barometric pressure for some of these stations. And here's what we call a barograph trace. And you can see how this really bottomed out here for Astoria. And then the big winds come when it rises. So the thing is about barometric pressure, you can see all this time when it's falling, you're really not getting that strong of winds at this point. So you have a good heads up if you have a barometer that some kind of storm is coming, and then this just powerful pressure rise when the most powerful winds just come roaring into your area is right here when this pressure starts to jump. Now this is looking, got an animation here of the precipitable water, and you can see it, atmospheric river that just slammed Central California, caught up all those flooding concerns and set all kinds of record rainfall there. And you can see a little pressure center curl up into the Olympic Peninsula there, looking back at 1995 data. Now look at this. You know, you can see that this jet stream here is marking a very powerful gradient between subtropical and tropical air to the south, and of course cooler air and polar air up to the north, or Arctic air. And then you can see that jet stream just racing across the Pacific Ocean there. And there goes the storm breaking right up into western Washington. And you can imagine all the moisture that this had in this immense pressure gradient slamming into California there. And now if we trace this back, you can see the development of this storm off the coastline of Japan here. You can see the parent trough and low over the Pacific Ocean here and the Gulf of Alaska. And you can really see the storm just kind of race across just north of Hawaii there. You can see that 978 millibar beast just being born as it rolls across the Pacific Ocean. And now you can see the west coast and the storm system continuing to develop here. I'm scrolling back and forth between the wider view and looking in a little bit more, and you can see it just really taking shape off the coastline here. Look at this 957 millibar low just off the coast of Northern California, and look at the immense pressure gradient on the south side. So you can see why the winds with the storm were so strong. And you can really see that gradient along the California coastline here, now beginning to take shape across southern Oregon. And as we look closer, there goes that low getting closer and closer to the Oregon coast. And look at this immense gradient. No wonder they got 120 miles per hour on the sea lion caves there on the Oregon coast. And now you can see the low start to slowly weaken as it moves up across western Washington, but it's still bringing some very intense winds to the area here. And as typical, once these start to move inland and usually up over British Columbia here, they start to fill. But look at the gradient here. When it was a 956 millibar low there, just kind of a beam, the California-Oregon border versus northwest of Santa Barbara, an amazing 60 millibar gradient. That's why those winds were so powerful blasting into the Bay Area. Now, taking a look at the winds here a little bit, you can kind of see how that relates to the gradient out there. And this is at 5,000 feet, very powerful winds up there. These are in kilometers per hour, but nonetheless, extremely powerful winds. This is kind of an animation here, and you can see that system here. There's December 12th, 1995. There it rolls across the area and breaks right into the Pacific Northwest. So you can see where this developed from. And we'll look at the precipitable water here, but it probably developed from some tropical depressions that had been lingering out here across some of the Western Pacific. And they interact with this trough here. And you can imagine that tropical and subtropical air is a much different temperature here than this very cold air aloft. And that creates that powerful gradient, the powerful jet stream, and it rushes the storm up into the Pacific Northwest. And here we are looking at this animation of this system moving up. You can just really picture the very intense pressure gradient along the Oregon coastline there. And you can also see the extent of the storm. This line here is 800 miles. So you talk about hurricanes versus mid-latitude cyclones. They're different monsters, but really the mid-latitude cyclones can cover much more area and they can bring stronger wind much further inland. They don't have that extreme storm surge along the coastline that some of the big hurricanes do, but the effects can be far more, far-reaching than actual hurricanes, these mid-latitude cyclones. And here we talk about it a little bit. Category 3, they can equal Category 3 in both minimum pressure and sustained wind speed. And like I said, they have far greater reach. Like some of these storms can impact all the way from Alaska to California, and they can cause billions of dollars in damage along their path. This is tropical depression area out here. And I narrowed it back. There was a few tropical depressions out there at that time. So it could have been remnants from either 32, 33, or 34. And I've traced this all the way back. You can see the moisture stream across the Pacific Ocean there and really point that powerful atmospheric river into central California there and come up the Oregon coastline and into western Washington. So interesting stuff that we can go ahead and look back in time and see these systems play out before our eyes. This is looking at 500 millibars, and you're looking at temperature. So you can see the tropical areas here, and then you can see the polar lobes kind of rolling off of Asia and then coming across the Pacific Ocean. And there was the storm. If you missed it, let's replay it again. You can see the polar lobe here. It comes across the ocean here. Powerful gradient, and there it comes rolling across the Pacific, and it's going to break right up the coastline there. That's our big windstorm. So yeah, that's really what drives these, is the big temperature gradient between the equatorial regions and the polar and the Arctic regions. So yeah, interesting stuff there. So that's kind of a breakdown there of the December 1995 storm. I'm going to be going over some other ones here as well. We're also going to go over the October 24th, 2021, only a couple of years ago there, where we had the huge bomb cyclone off the Pacific Ocean coastline. You guys probably remember that one. And we will go over that in some detail as well as a few other storms to get some honorable mention. And I've got a couple more storms to go here in the series, and I'm going to save the best for last. I'm sure a lot of you guys know what number one is, but it's going to be fun to cover nonetheless because there's so much literature on it. There's so many different stories, and there's so much meteorology to cover with that monster number one windstorm, which will be coming up here probably in the next month or two. I'll start working on that next. But anyway, hope you guys are liking these videos. I'll do my regular briefings tomorrow, and I will talk to you guys then.